Good morning, all, and you're very welcome to this session of the Intertrade Ireland All Ireland Innovation Speaker Series, which is focused on the entrepreneurial ecosystem and the role that the university plays in it. Today, I'm delighted that we're joined by Professor Riccardo Fini of the University of Bologna. Riccardo is the PhD Programme Manager at the University of Bologna and is also the visiting professor at Imperial College London and Nord Business School in Bode. His research interests include entrepreneurship, science commercialization and its impact, and he has published in prestigious journals such as Research Policy, the Academy of Management Journal, Entrepreneurship Theory and Practice, and the Strategic Entrepreneurship Journal. Today's talk, Riccardo will talk about disruption from the university lab, how science impacts entrepreneurship and its impact on nurturing the ecosystems in the area. So Riccardo, thank you very much for joining us. I'll shut up now and I'll hand over to you. The floor is yours. Thank you very much.
Thank you very much, Lawrence, and thank you all for being here. And I'm very, very happy and flattered by this invitation. And before getting started with the actual talk, let me say that the vast majority of the research that you will be seeing streamlined and presented over the next 25 minutes has been supported by the European community through the Marie Curie Skolkova actions, and I'm very happy and proud to say so. With that said, as Lawrence just anticipated, I do research on academic entrepreneurship, technology, innovation management, and in particular, I've been focusing on university ecosystems and their impact. So this audience very much know how universities can generate impact. So there are three main facets here, three main actors: teaching, research, and academic engagement and commercialization. So as universities has been able to deliver impact throughout the last 100 years, very, very recently in 2014, through the UK Research Excellence Framework, there's been one of the first attempts to systematically evaluate and measure the university impact. And you see the definition of impact reported on the slide. So as we do agree that research and teaching are clearly play a major role here, are key ingredients of this process, in today's talk I'm going to be focusing mostly on the third mission activities, namely academic engagement and commercialization. So on this slide here, I have listed on the left-hand side the academic engagement activities, namely industry collaboration, consultancy, advisory board, and civic engagement. On the right-hand side, I do list the commercialization-related ones, in particular the disclosures, patents, licensing, as well as spin-out creation, entrepreneurship. And if you look at what happened to date across the globe, we can come up with some very exciting successful stories of academic engagement and commercialization. Think, for instance, about the rocket technology back in the 30s at Clark universities, or think about the human insulin in the 70s, discovered and developed at Harvard, at the University of California at San Francisco. Or also the Gatorade, the patent for the Gatorade in the 70s at the University of Florida, and more recently the flu vaccine in the 80s at Rochester. As here I've just focused and listed a few great cases of commercialization based in the US. We can think and we can come up with some others that are more that are closer to us. Developed at EU-based universities. With that said, though, I think perhaps some of you have started asking themselves whether this is actually a rare event, whether commercialization is something that relates and involves STEM universities only, science, technology, engineering, mathematics, and medical, and whether the impact of commercialization is actually sizable and important. And these are all fair requests that are by our society. They're also known as taxpayers. So moving from these questions, over the last 10 years, I've tried to shed lights on this phenomenon. And now I'm going to be presenting some of the results of these research pipeline. So first of all, here, I really would like to draw your attention on the TRIC project. TRIC project is a project that is based at Imperial College. And the aim of the TRIC project is to obtain a full picture of the academic engagement and commercialization at Imperial College, identifying the drivers and the enablers of these activities. So in doing so, with some other colleagues, we systematically studied the impact of the 10,000 academics employed at Imperial College between 2000 and 2012. We collected primary and secondary longitudinal data on their efforts, and in particular, we focused on their publications, their disclosures, their grants, their patents, their consultancy activities, and their spin-out efforts. In this slide here, I start skimming through the academic engagement, a few of the academic engagement activities. In particular here, I focus on industry collaboration and consulting activities. The effort here is try to understand whether we are capturing all academic engagement and commercialization activities, or whether we are systematically underestimating the phenomenon. Here, in this column here, I report the figures according to the university records. Let's call them supported activities. As per the university records at Imperial College, each single scientist per year have been involved in roughly 20,000 pounds of industry collaborations. The percentage of the staff involved is 29%. As per the consulting activities, academic scientists consult on average for 2,500 pounds per year, and the percentage of the staff involved in consulting is about 12%. You see here that by combining the internal university records with other data sources, in this case, primary data collected directly from researchers, we managed to estimate the real amount of consulting activities at Imperial, that is about 5,000 pounds per year per individual, with the 41% of the staff being involved in this. The underestimation here is roughly 50%. As per the commercialization activities, in particular patenting and entrepreneurship, according to the university records, we have 2.7 per 100 individuals involved in patenting, with the percentage of staff involved equal to 2.8%. As soon as we combine the internal data with some external data, in this case secondary data, we find out that we have 3.9 per 100 individuals involved in patenting, with a 3.2% of the staff involved. The underestimation in this case is roughly the 30%. At different figures, more severe underestimation comes with the entrepreneurship activities. We have 0.3 individuals per 100 involved in entrepreneurship, 0.4 of percentage of the staff involved. As soon as we combine this with other sources, external sources, we find out that we have 3.6 individuals per 100 involved in entrepreneurship, and the percentage of the staff involved is equal to 3.3. The underestimation is about 92%. So that was the first important, we think, result of this thing, of this effort, of this project. We tend to underestimate academic engagement and commercialization at our universities. Then, you know, the second part of this of the exercise here was related to trying to characterize the individuals, the scientists who do engage in entrepreneurship, vis-a-vis those who do not. So to do so, this is a US-based effort. We surveyed the population of US tenured and tenure track faculty members employed by the Carnegie I and Carnegie II universities in the US. We collected almost 12,000 responses, collecting information on the academics' demographics, their rank, their activities, and their commercial outputs. The first result here is that we do see that entrepreneurship happens across all the different disciplines: engineering, biomedical sciences, social science and humanities, and physics and mathematics. The highest percentage of entrepreneurs happens in engineering, with almost 30% of the scientists researching in engineering being involved in an entrepreneurial effort. What is also important, we think, is that also in social sciences and humanities, some researchers are looking at entrepreneurship. 11% of them, they have been involved in entrepreneurship to date. The second part here, related to this US-based study, is about their demographics. So we do see that the vast majority of entrepreneurs are male, 89% here, you see. So female entrepreneurs are underrepresented in this study. When do academics engage in entrepreneurship? Is there a life cycle of entrepreneurship? Apparently, yes. The likelihood of having entrepreneurs among scientists that are, let's say, junior ones, years in academia between 0 and 10, is lower vis-a-vis the scientists that are more, let's say, senior ones. So basically, these data is suggesting that typically academics, they tend to engage in entrepreneurship only in their, as you know, they move ahead in their academic life cycle, as you know, this data is suggesting. Last point here related to the US-based study is that if we focus on the 1,829 entrepreneurs, we find out that only 37% of them started their business based on a patented technology. 63% of them ended up starting their business on a technology that is non-patented, or a technology or innovation that is not patented. So here we see that we can say that academic entrepreneurship is not happening only within the intellectual property system. There is also quite a sizable part, 60, almost 2/3 of the entrepreneurs are engaging in entrepreneurship outside the so-called IP system. So perhaps, you know, now the big elephant in the room here is perhaps basic science. So we know now that scientists engage in academic in commercialization, but perhaps we still don't know whether this is going to be beneficial or not for their basic science efforts. So moving from these question, we designed a study, still based on the Imperial College data, to aim at measuring the effect of academic entrepreneurship on the production of scientific knowledge. So apparently, according to the existing literature, we do see trade-offs here. On the one end, literature suggests that there are potential benefits for scientists who do engage in entrepreneurship. In particular, entrepreneurship provides new research ideas and allows exploring new domains within their research effort. Some other research suggests that the subsequent research output of the scientists who do engage in entrepreneurship may be more novel and impactful. On the other hand, though, there might also be potential costs. In particular, entrepreneurship might prevent the scientists from pursuing the basic science and might originate a fragmentation in their academic profile. If they do engage too much the commercial logic, they might be perceived as not as being scientists anymore. So by building on this, moving from these intuitions and this evidence, by the way, we start interviewing researchers at Imperial. And you see a couple of quotes that has been collected during interviews with academic entrepreneurs. So in general, what they do suggest is that entrepreneurship, by engaging in entrepreneurship, they ended up exploring more, discovering new things, moving away from their basic science trajectories and starting new research endeavors. Second, and related, their research, their subsequent research apparently ended up becoming more impactful, because there, you see the first quote here, through the commercial work, they've been able to identify what is important. So these were just, anecdotal evidence spurring from some very interesting, in-depth interviews, but with a very limited number of scientists, of course. So we try to look for patterns in our data to confirm or perhaps disconfirm these anecdotal evidence. And so, based on the literature, we built this model, and we tested this model. So, according to the literature, we can put forward a few hypotheses suggesting that entrepreneurial entry is going to be having an impact on exploration, and through exploration, the subsequent research of the scientists might become more impactful. You see exploration and research impact when they are measured at time t, and at time t+1 and t+4 for research impact. And now the research on how exploration and research impact have been measured. Our results suggests that the odds of exploration are 30% higher for entrepreneurs than for non-entrepreneurs. And the entrepreneurs almost double their research impact, their subsequent research impact, after they've been engaging in entrepreneurship. So we see here that basically we managed to confirm the anecdotal evidence that was suggested by the interviews with the researchers. So not only the downstream application activities help the researchers to escape from the scientific trajectory, starting exploring more, but also the research becomes more impactful. A few caveats and boundary conditions apply to this overall picture. So first of all, our data suggests that 10% of the academics are responsible for 90% of the research contract volume and almost 98% of the consulting volume. So these activities are very, very skewed. Other evidence suggests that academics that engage industry are typically systematically positively evaluated by their peers. If they end up engaging too much behind a certain level, they do risk what we call devaluation, meaning that they are not perceived anymore as scientists, and they lower their chances of raising public research funds later on, meaning that their peers do not evaluate them positively anymore. Another important, we think, aspect that we would like to bring up to your attention is the fact that we as researchers and perhaps also as policymakers, we have been very, very much focusing on, for instance, the number of spin-outs, academic spin-outs that has been established by our universities. So if now we move to Italy, and if I do, let's say, present you some figures on the Italian context, a context that I know extremely well because I've developed my own doctoral thesis here at the University of Bologna, and I studied the population of the academic spin-outs that has been established by the population of Italian universities. And so we can say that roughly there are 2,500 academic spin-outs that have been established as of today, by the way, by the Italian universities so far. What we also know, though, through some more recent studies, is that the students-led startups are actually 250,000. So you see here the ratio is 1 to 100. So if we do just, systematically focus only on the so-called university science-based spin-out, perhaps, we're not capturing the overall picture, and perhaps we are systematically underestimating the impact of our universities. Because one aspect that is also important to emphasize is the fact that the students who have as an academic mentor a tutor, an instructor that is also an entrepreneur, for these students, the odds of becoming entrepreneurs are significantly higher vis-a-vis those who had a tutor, a mentor, an instructor that was not an academic entrepreneur. So you see how universities can actually maximize their impact on students, of course, but also on the regional innovative ecosystems surrounding the universities. So perhaps, this is idiosyncratic, is specific to Italy only, but we know we have some notable example of the importance of the universities in creating an impact through their innovation, through their teaching and research, of course, through the surrounding regional ecosystems. And here I just want to conclude briefly on skimming through some very notable examples of how the three actors of the triple helix, by collaborating, have been able to generate impact at the regional level. So all the great cases of Stanford and MIT. What I think is interesting to pinpoint here is that how much they've been able to, what kind of impact they've been able to generate. So according to some published research, there are about 40,000 active companies that can trace their roots to Stanford, These companies have created more than 5 million jobs with annual revenues equal to 2.7 trillion. Same thing for MIT, with 30,000 active companies that can trace their roots to MIT. These companies have created 4.6 million jobs with annual revenues of about almost 2 trillion. There is also the great case, interesting case of Israel, that is now the nation with the highest number of startups per capita in the world. These entrepreneurial efforts have been significantly boosted and driven by the government's innovation policy that has been focused on three specific grand challenges, namely agriculture, climate, and security. And by investing and by supporting innovation and entrepreneurship in these three domains, they managed to generate one of the most vibrant regional ecosystems in the world. Recently, though, some researchers and policymakers have been challenging the triple helix framework by saying and suggesting that civil society should be also included in there. So not a triple helix anymore, but a quadruple helix model. And by focusing on this, by bringing the civil society in, I just want to briefly present the Emilia-Romagna case here. So Emilia-Romagna is the region that has as capital town Bologna. The University of Bologna is based there. So Emilia-Romagna is very well known for excellence in automotive. Think about Ferrari, Lamborghini, Ducati, and so on. Automation. There are the world leader factories, Coesia and IMA, for automated packaging lines and machines. Of course, food, as well as, wellness, more toward the Romagna part, so with technology. So why I'm saying this to you is because these companies, notwithstanding the fact that we have 5 universities, STEM universities, generating every year thousands of engineers, these companies have been struggling in finding human capital, in finding engineers, in finding technicians that could be able and capable of being hired and being introduced and employed in their organizations. So what they did, they joined forces with the region, and in particular with the Coesia, in a Coesia-driven effort. They joined forces with the Scholastic Office of the Emilia-Romagna region, and they launched this Project Expedition. The Project Expedition is an effort that has been operating since pre-COVID. I would say that was started in 2018, even earlier. And the idea is to train some high school students, high school kids, and been exposing these high school students to the culture of innovation in advanced mechanics, and having these students participating to some projects based at in these factories, Ferrari, Lamborghini, Coesia, and so on, having university instructors joining and sharing their vision and their thoughts to disseminate, to create the culture of innovation and entrepreneurship in the region. This program has been extremely successful, and by engaging high school students, we basically managed to have students that were employed right away after graduation, after high school graduation by these universities, some students that were actually starting their own business, their entrepreneurial efforts, some other students, of course, going, for the university degrees and diploma. So in this case, I think a very interesting, virtuous quadruple helix effort has been characterizing this region. So let me now conclude by saying just a few words and by systematizing what we have been seeing together. So academic engagement and commercialization occurs across all disciplines, both inside and outside the IP system. Academic engagement and commercialization activities are those skewed. Relevantly few individuals account for the vast majority of the activities. The academics who do engage, they systematically have stronger scientific profiles, but become even better after the engagement and the commercialization, as the downstream activities benefits upstream research basic ones. Downstream impact relevant activities are typically pursued when they chime with the scientific agenda of the academics. So in this case, I think we can safely state that impacts needs to come from within science, as the academics really want to drive those innovations that are a result of their novel scientific efforts. If we just take a step back and put everything in perspective and how this is going to have an impact on our regional innovative ecosystems, we can clearly state that university excellence is driving impact. But university excellence by itself is not going to be enough. Regional industrial munificence, the sharp governmental industry policies, and ways to engage the civil society are all important ingredients. They need to be there if we want to drive impact. The aim here is to have policymakers, university administrators, managers, and entrepreneurs collaborating and looking for a global optimum rather than for maximizing some local ones. With that said, I really want to thank you all for the attention. This is my email in case you would like to get in touch. And at that link, you might retrieve some of the research that has been cited in this talk. Thank you very much. Back to you, Lawrence.
Ricardo, thank you very much for a whirlwind tour through academic entrepreneurship and some of the issues that we all understand that we're undervaluing and under measuring the amount of entrepreneurship and contribution to society which is going on by the universities. And given the tightness of financial allocations from our paymasters, I think the more we can highlight our contribution, the better for everybody concerned, both the university and the ecosystem itself. I'm going to stop the recording now just to allow people to ask questions of Ricardo. But before I do, I'd again like to thank Ricardo for giving his time and for an excellent presentation. I'd like to thank all of you for attending the sessions over the last 3 days by Professor James Cunningham, by Professor Nola Hewitt, and our recorded sessions as well by Sarah Lubbock and so on. I'd encourage you to click on the pre-recorded sessions. The 2 recorded sessions coming up today relate to the National Innovation Protocol and ITI's equity division and how they are enabling and supporting startups and their upcoming equity VC conference in Croke Park in March, please God, if COVID maintains or behaves itself. So I'm just going to stop the recording and wish everybody a safe and happy Christmas, and then we'll take some questions now.